This is the last video. This is section 6.6, example 2, creating a model for an optimization problem and solving the problem. This is exactly like we did in example 1, except all this is new. We're going to have to do it all from scratch. Shouldn't be a problem. Let's find out. The question goes, L&G Construction is competing for a contract to build a fence. The fence will be no longer than 50 yards and will consist of narrow boards that are 6 inches wide and wide boards that are 8 inches wide. There must be no fewer than 100 wide boards and no more than 80 narrow boards. The narrow boards cost $3.56 each and the wide boards cost $4.36 each. Determine the maximum and minimum costs for the lumber to build the fence. This is a good problem. A lot of you guys will own a house one day and you'll want to build your own fence. So let's get right into it and we'll see how much it's going to cost to build this lovely fence. First step, our variables. We'll talk about N for narrow boards. W will be our wide boards. And C will be the cost of lumber. We'll use that for our objective function later on. Step 2 is the restrictions. We're talking about boards. You're not going to go to the store and ask for a half a board. So you're going to buy them in whole numbers. So we know that the N is going to be an element of the whole number system, and W is going to be an element of the whole number system as well. We'll move on now to our constraints. It says that there are no fewer than 100 wide boards. So that means wide is going to be greater than or equal to 100. It says there are no more than 80 narrow boards. So narrow is going to be less than or equal to 80. And it also says the fence is no longer than 50 yards and is made of 6-inch narrow and 8-inch wide boards. So what we have to do for that one, a little bit trickier. We know that the narrow boards are 6 inches, so we'll go 6 inches per narrow board. We know the wide boards are 8 inches, so 8 inches per wide board. And it's going to be, since it's going to be no longer than 50 yards, less than or equal to 50. I hope you guys are looking at that and seeing a problem with it. We've got 6 inches, 8 inches, 50 yards. So in order to make the units the same, we're going to have to convert our yards to inches. And the way we do that is by multiplying by the fact that there are 36 inches in a yard. So I'm going to just erase the 50 times 36 and change that to the number of inches in the whole fence, 1800. Wide boards, greater than or equal to 100 of them. Narrow boards, less than or equal to 80 of those. 6 inches per narrow board, 8 inches per wide board is going to be less than or equal to a total of 1800 inches, 50 yards. That's step 3, all said and done. Next thing we have to do is come up with our objective function. We know that narrow boards are $3.56, $3.56. Wide boards are $4.36. So we can say that our total cost is going to be $3.56 per narrow board plus $4.36 per wide board. So just to review what we've done so far, we've got our step 1, our variables, our step 2, restrictions, step 3, the constraints, and step 4, the objective function. Before I move on, I guess one thing that I could add to that step 3 with the constraints, we know that we can't have less than 0 boards. So we can say that narrow boards have to be greater than or equal to 0. Our wide boards also have to be greater than or equal to 0. Something that we should throw in there as well. Step 5 is going to be to graph it. Now we've got a graph just about ready to rock here. We'll start by going ahead and labeling this 40, 80, 120, 160, 200, and 240. This is going to be N for narrow boards. Up the side, I can do the same idea. 40, 80, 120, 160. I should go right here, 200, and 240. And that's W for wide boards. We have to look at the fact that we have whole numbers, and equality as possible. So we know now that we need stippled green boundary points and orange shading. So we'll take a look at that first constraint of W being greater than or equal to 100. So we know that at this point that these are just going to be horizontal lines. So I'm just going to go to, this is 100 right in between, right about here. Should be right here. So I'm going to make my green boundary points right across. Looking good. I can look at the other one being n is less than or equal to 80. So again, that can just be a vertical line right up here. Those are the easy ones. The one that's going to challenge us a little bit more is the 6n plus 8w is less than or equal to 1800. Now at this point, you guys are getting pretty good at figuring out how to do this. The one thing we can do is determine the n and the w intercepts. I trust at this point that you guys all know how to do that. So very quickly, we'll find that the n-intercept should be at 300 and that the w-intercept should be at 225. So I can just go ahead and plot those 2 points. So here's 300 on the n-intercept, and 225 will be approximately right here. We can now connect those 2 points with a green stippled boundary line. Do our best to find those whole number values. A little bit challenging when you have such numbers. Now we got to determine our shading, where we're going to have to shade. For this one, W has to be greater than or equal to 100. So I'm going to definitely shade above this one. This one right here, N has to be less than or equal to 80. So I'm going to shade to the left. And then the other one being 6N plus 8W has to be greater than or equal to 1800. Less than or equal to 1800. If I substitute 0 for N and 0 for W, as Aaron astutely pointed out in class, I would end up getting 0 is less than or equal to 1800. That's lovely. That's a true statement, which means that region below that oblique line is going to be our shaded region. I hope Clark doesn't get mad at me for using red instead of orange, even though I don't have an orange marker. But this is going to be our feasible region right here. Shade it in with orange, and then we'll use our green stippling in there as well. Now remember that when you guys are doing this with your orange pencil crayons, you're going to shade all the regions, not just the feasible region. If I were to shade the whole thing, everything would just look like a big red jumbled mess. Next thing we're going to want to do here now is find the coordinates of these boundary points in the corners. You're going to have to kind of estimate a little bit because of the fact that there's going to be 5s, etc. here, but we'll do our best. This corner has coordinates, I'm going to use the black marker for this, has coordinates 80 and about 165. This one down here has coordinates 80 and 100. Over here we're looking at 0 and 225, which was our w-intercept from earlier. And this one down here is going to be 0 and 100. So those are going to be our 4 corner, 4 boundary points, and that's going to help us when it comes to trying to optimize. Because there are 4, because we've got a quadrilateral as a feasible region, we're going to have to optimize 4 different times. So we better get going. Our objective function, C equals 356, N should be right here, 356N plus 436W. We'll bring that down here. And we're going to optimize to make sure. So, first point, 0 and 100. We'll go C equals 356 times 0, using 0 narrow boards, plus 436 times 100, using 100 wide boards. Do all the math out on that. We should get a total cost of $436. So if we were to use no narrow boards and 100 wide boards, we'd have a cost of $436. For the point 0, 225, we will go C equals 356 times 0 narrow boards plus 436 times 225 wide boards. The total cost for that, doing the math all out, is going to be $981. So the cost of using 0 narrow boards and 225 wide boards would be $981. Use the next point, which would be our 80 and 100. So again, we'll put 80 and 100 here so we know what we're doing. C equals 356 this time times 80 narrow boards plus $4.36 times 100 wide boards. Do all that math out, we're going to get a total cost of $720.80. So the cost of using 80 narrow boards and 100 wide boards is $720.80. And the last one would be 80 and 165, 80 narrow boards and 165 wide boards. C will equal 356 times 80 plus, what was it, 436 times 165. Do all that math out, we will get a total cost of $1,004.20. Clearly we have a minimum and a maximum. Our minimum value is $436. Our maximum is $1,004.20. I guess these guys have to look at these minimum and maximum values, I guess, to optimize their costs. That being said, they also have to look at how long the fence has to be. They talked about how it's no longer than 50 yards, but, I mean, if they want to enclose their yard so their dog doesn't get out or something, you want to make sure it's going to cover your whole yard. So these things, this would just be the minimum and maximum cost for doing a fence that's less than 50 yards with the constraints that we've been given. Are we finished? Nope, because we have to verify our minimum and verify our maximum. That's the last thing we have to do. Remember to do that, we're going to go back to our 3 primary constraints. W greater than or equal to 100, N less than or equal to 80, and 6N plus 8W is less than or equal to 1800. We're going to take our values of N and W from our minimum and maximum points, substitute them in to make sure we get true statements. We'll do the minimum, so we'll verify the minimum. The minimum point was at 0 and 100, as you will recall up here. Using only 100 wide boards will be $436. We want to make sure that those parameters satisfy, those points satisfy all 3 of our inequalities. The first one was N is less than or equal to 80. N was 0. So 0 is less than or equal to 80. Satisfied with that. The next one was W. It's got to be greater than or equal to 100. W was 100. So that is greater than or equal to 100. And the last one was 6N plus 8W is less than or equal to 1800. We'll put in 6 times 0 plus 8 times 100. It's got to be less than or equal to 1800. That'll work out to 800 is less than or equal to 1800. Those 2 points, 0 and 100, satisfy all 3 of the inequalities. So we have verified the minimum. And the last thing we have to do is verify our maximum. The maximum point, you'll recall, was found at 80 and 165. That was where the cost was $1,004.20. So we'll do the exact same thing. N being less than or equal to 80. N was 80, so we will go 80 is less than or equal to 80. Checks out. The next one, W is greater than or equal to 100. W is 165, which is greater than or equal to 100. That works just fine too. And then we should have 6N plus 8W is less than or equal to 1800. Substitute 6 times 80 plus 8 times 165 should be less than or equal to 1800. We would get, when we do all that math, we get 1800 is less than or equal to 1800. Checks out. So we have verified both the minimum and maximum. Grade 10s. This is the type of question you're going to get in an exam. There's a lot involved with this. Nothing is crazy difficult, but there is a lot involved. Step 1, we've got our variables. Step 2, we have our restrictions. Step 3 is our constraints. Step 4, our objective function. Step 5, which is a big one, graphing it. Step 6 is to optimize the objective function to determine the minimum and maximum costs. Step 7, verify the minimum. And step 8, verify the maximum. There's a lot involved. Grade 10s, if you want to get full marks on your tests, on your exam in June, you need to do all of these steps and do them correctly. that's going to wrap up the unit. I hope you guys enjoyed watching these videos. I was going to say as much as I enjoyed making them, but I hope you enjoyed them more than that. Make sure you come to class tomorrow as per usual with lots of questions and ready to work. And we're going to be next day working on our unit review in preparation for our Unit 6 exam. Good work, everybody. Enjoy your night.